good evening, everyone, and welcome to the BS and Beer show. BS stands for Building Science, of course. I don't know what you were thinking. Our goal at the BS and Beer show is to spread BS far and wide and to have fun doing it. My name is Mike Maines, and I'm going to introduce my beverage. I'm drinking tea, shameless plug. My wife makes herbal teas and skincare, so Ridgefarm Herbals tea, locally made. Tonight's topic is concrete-free slabs, or at least reduced concrete-free slabs. If you're not sure what that even means, that's what we're here to talk about. I have designed one myself based on some input from the people in the discussion here. I don't think I have much to add that they won't cover, so we'll put a link to an article I wrote about it in the comments section. But for the most part, we have a lot of people who have done this and have different ways, so we wanted to hear what they have to say. What else? We're excited that participation is growing. The BS and Beer concept and just the discussion group concept seems to be growing. So thank you to the panelists. Thank you to the audience for helping us make this a thing. The Zoom format is great, but we also really want people to start local groups. A lot of building science is universal, but a lot of it is really specific to your local area. So there's somewhere around 10 BS and Beer groups now, plus maybe 10 with other names who have been around a while. Feel free to start your own. We're working on a BS and Beer website that will have some tips. The name isn't copyrighted or anything, so feel free to use it. We just ask that you don't use it for commercial purposes, of course. And I would like to thank Green Building Advisor and Fine Homebuilding Magazine for being our media sponsors. They've helped us spread our reach, and they're hosting our videos, so really appreciate that. And I would like to finish my introduction here by introducing the other hosts, Emily Mottram, Travis Brungardt, and Brian Pontolilo. And I'm going to turn it over to Emily.
Hey everyone, Emily Mottram. I'm an architect here in Maine. Mike and I just kind of like to talk building science. So if you haven't heard, Mike and Travis and I just recorded a podcast. It'll be up in the next couple of weeks. E3 Energy and Efficiency with Emily. And if I can get smart this weekend, I'm going to push it to, I believe, Spotify and maybe another Google podcast player for all you non-Apple users. So right now you can get it on Apple or on my website. I'll put some links in there. If you're not already on our mailing list, I'm going to put a link in the chat box to the mailing list. That'll give you a reminder about the BS and Beer show beforehand, and occasionally we send out a poll or a questionnaire about topics or times, etc. The video will be available after this on Green Building Advisor's Building Science blog. So if you miss an episode or a week, or you've missed any of the previous ones, you can check it out on Green Building Advisor. Or we also have a YouTube channel, the BS and Beer Show. So I'll put a link to the YouTube channel for the BS and Beer Show as well, and you can catch previous episodes. But tonight, I'd like to briefly introduce our guests. I'm going to just say your name, have you raise your hand, and then I believe the chat is going to let each of you talk about your system, and you can tell us a little bit more about yourself then. So we have Steve Basic. Please, if I say your name wrong, correct me. Steve Demetric.
Yep, you got it.
Okay, Elizabeth DeSalvo. All right, also Andy Engel. Okay, we've got Josh Salinger and Randy Williams. So I'm also going to add to the chat box a link to all of their websites so you can connect to them afterwards if you have more questions about the chat. So now turning it over to Brian, my co-host for the evening.
Hey everyone. Brian Pontolilo from Fine Homebuilding and Green Building Advisor. And I'll keep this really quick. My job tonight is going to be to monitor the chat box. And so what we're going to do for a format is we're going to have all of our panelists tonight discuss a little bit about what they've done or their understanding or even their curiosity of concrete-free slabs, and that'll take about half of our time, we think, and then we're going to switch gears at that point and take questions from y'all. And the way we'll take questions is through the chat box. So if you want to, if you can wait a little bit to post your questions, it'll be easier for me to spot them when we get to the second half of the show tonight. So that's about it for me, and thrilled to be here.
I forgot to mention I have Sam Adams, since this is a beer show, supporting Fenway and baseball and the sports, the official beer of the Boston Red Sox. Totally forgot. It's BS and beer.
Okay, I forgot too. It is a BS and beer show. Like Mike, however, it's tea tonight. Orange clementine, sweet clementine, something like that.
Back up, Travis.
I'm drinking the real thing. It's a
Travis.
from Free State. So this is good stuff. I'm a fan of the sours, and this one's exceptional from Free State and Lawrence. But you guys enjoy your tea. There's nothing wrong with that. I'm excited to be with everyone tonight. It's great to have everyone here, and especially for me, because I am not an expert in concreteless slab technology. So I get to do a lot of listening and drinking, which is a win-win. I would like to propose a toast along that line. I actually had to look this one up because I wanted to do something to honor my Marine Corps friend, Steve Basic, who's in the panel tonight. And this is the one that I found that I liked, and we'll see if Steve approves. If the ocean was beer and I was a duck, I'd swim to the bottom and drink my way up. But the ocean's not beer and I'm not a duck. So raise up your glasses and shut the F up.
I like it.
Cheers.
I have a few more that are probably a lot more colorful than that. But
I cleaned that one up a little bit. I would like to hear more about our panel tonight. We got a lot of great people here, and some of them I know, but some I don't. And since Steve's already talking, you want to start us off, Steve, and just introduce yourself and tell us a little bit about yourself? I already outed you as a Marine Corps, a Marine forever.
Yeah. So my name's Steve Basic. I'm a registered architect, registered in a number of states, operate around the country, doing what I think are some pretty interesting things, but some of which I had the opportunity to build a couple of concreteless slab buildings. One with the panelist here, Steve Demetric. I did a whole house down in Missouri with Jake Bruton. That was pretty successful. Turned Randy onto it. Randy built a beautiful house up there in Minnesota using the ideas. So, you know, just trying to push forward and think about different things. And, you know, when, not to steal Steve Demetric's thunder, but when we were doing that project, he simply asked the question of, do we really need to put a slab in, which kind of kicked the ball over the top of the hill, and it started rolling down. So
nice. With that in mind, since you mentioned Steve Demetric, do you want to kind of introduce yourself, Steve? And
Oh, sure. I'll introduce my beer too from across the tracks at Kingston Station. Shades on beer, Rhode Island Pale, very good. So my name's Steve Demetric. I'm a builder in Southern Rhode Island. Our company specializes in passive house and net zero construction. We've done 2 certified passive houses out of the 3 chart-topping numbers in our state. But since the first one, though, all of our projects have either been passive house certified or net zero or aligned in some fashion. We basically just drew a line in the sand, and that's all we do. And actually with the slab work, I mean, we just kind of like Steve said, we just questioned something, and which is kind of what got me into high performance building in the first place, is just the idea of questioning things to find better ways of doing things.
Nice.
I think, I think one of the things that drives ideas like this is, I constantly find myself saying, if we build house number 2 the same way we built house number 1, we're doing something wrong as a professional, meaning that we should be able to learn something from the last house that we did. And, again, when Steve and I sat down, we basically started below the footing and went up through the roof of the house and questioned everything. Now, a lot of things stayed the same like we've done before, but we did make some changes out of it. So, innovation is certainly a discipline that's sometimes born out of doing the same thing over and over and then simply questioning, is there a better way?
With that with that question in mind, do you want to introduce yourself, Randy, and tell us a little bit about yourself, since you also asked the question?
Sure. Well, I'm Randy Williams. I'm an energy auditor. I do some design work. I'm in northern Minnesota, the Climate Zone 7.
What's the heating degree days there, Randy?
We're right around 10,000. It's chilly. We actually got above freezing today. It's been a while since we did, so still a little snow on the ground. Anyways, so I read the article from Steve and Steve on the slab that they eliminated the concrete on, and the idea kind of stuck in my mind for a little while. Ended up with a customer that it was a good fit for. And really what I wanted to do is eliminate the picture behind me. My climate has got a lot of heated slabs, and that's the one behind me is one of the worst I've seen. That was leaking a lot of heat out the foundation. But that was
an architect in Connecticut, and I too am really into innovation, and we've been building, we started, way before LEED existed, building super energy efficient homes, and then got into LEED, and then now we do passive house and net zero. We're probably done, I don't know, we're on our fourth or fifth passive house right now. We have builders we work with all the time, and we too saw the article by the Steves and decided to try that. So we first did a 3,000 square foot, 1-story house with all slab with slab. And then we did a couple other smaller portions of houses with that. And then I had, I used to do this thing where I would put floor joists standing up on top of a slab so that I could feed stuff through there, like plumbing and electrical. So the last house we did, we just did TJIs, 11 7/8 TJIs on top of the slabless slab, and we filled that floor with we just used that floor as the plenum for everything, because we were basically building a slab on grade and a flat roof house, and it worked really well. So that was my innovation, twist on the slabless slab.
Very cool. Moving on down the list, I don't know Josh either. Josh, would you introduce yourself?
Yeah, nice to meet you, Travis, and it's kind of an honor to be here with everybody. I am way out here in Portland, Oregon, so I think I'm the only one on the left coast out here. So thanks for all you East Coasters, and I suppose we've got someone from Minneapolis here, but great to represent. I am drinking a Barrelick Brewing. It's a IPA. This was brewed about less than a mile from where I'm sitting right now, so I want to give them a shout out for making delicious beer. And yeah, I suppose my innovation, a little bit about myself. My company is Bird's Mouth Design Build, and we build zero energy and passive house homes here in Portland, Oregon area. We built our first zero energy home back in 2013, 2014. And since then, we've certified 2 with FIAS, and we've got a 3rd underway right now. And it's always just been a kind of a passion of mine to always try to strive to do better. And amongst that, with our buildings, it seems like, we've kind of figured out the zero energy thing. And at least there's a lot of really good ideas out there. And I think a lot of people have been doing a lot of good work with that. But the next kind of, thing to look at is the embodied carbon. And so, to get rid of the concrete, especially when, buildings themselves contribute up to 40% of all the greenhouse gas emissions in the United States, to be able to not only make zero energy buildings, but address that embodied carbon is really important. So I'm really happy for this discussion. My idea kind of came to me, I'm prone to taking baths in the evenings, and this was back in 2015. I was sitting in a bath, and as I often do, I'm just kind of thinking about how can we improve wall assemblies, and I assume this is what everyone does in the evenings. But I had just come from a CLT conference, and I was like, well, I use these things for walls and roofs. Why couldn't we use them for slabs? And so thinking about trying to make an all wood assembly, and kind of it occurred to me, like, why couldn't we use this as an option, just instead of concrete, use CLT, which is wood, which is something that we haven't done yet. We've gotten very close to a couple of clients biting on this. There's still some things to be thought out with it, and I'd love to get feedback from everyone here about that. So,
or we will once we get through introductions, we'll go back through and everybody will have a chance to kind of explain their system briefly with photos if we have them, and so that will be the sort of the end of this first phase. Everybody can talk a little more about their system.
Yeah, we're almost there. We just haven't heard
yeah.
from Andy yet. If Andy would like to introduce himself. Hi, Andy.
Sure. Hi, Travis. How are you?
Very well.
I'm drinking a Treehouse Dark Czech Lager. Treehouse Brewing up in Massachusetts. They're just incredibly awesome. I also live in Connecticut, like Elizabeth, not too far from her, although we've never met. I'm a remodeling contractor, former Fine Home Building editor. In fact, I knew Brian when he was an intern, so that tells you a little bit how old we both are. And Mike tells me that I had some influence on this whole thing with an article that I wrote for Fine Home Building in 2005 called the Stay Dry, No Mold Finished Basement. And I was refinishing a basement for a friend, and he wanted to preserve as much headroom as he possibly could. And what I ended up doing was putting down a layer of EPS foam. I don't even remember how thick anymore. It's been so long. And
it was 1 inch.
Okay, thank you, Steve. You've read the article more recently than I have. And then a floating floor of 2 layers of CDX screwed together. And then we went over that with cork, and it is still there today. I was on it a couple of months ago. It worked fantastically.
Excellent. Thank you everybody for the introductions. Maybe just to for anybody who may not understand why you would even want to minimize or reduce concrete in a slab, can we just hear from somebody? Why might you want to reduce or eliminate the concrete in the slab? How about Steve Demetric? Do you want to?
Actually, I'll start off by saying that the carbon footprint of the building had absolutely nothing to do with what started the ball rolling for us. It's interesting that it's become this. But actually, I had seen Andy's article, and we did that a few times, and it worked great in basement remodels. And that's what kind of got I kind of planted that idea from Andy. But then what the real motivation for us was we were trying to figure out how to install hardwood floors in a walkout basement finished over fresh concrete. And because the concrete has so much moisture, it's a passive house, it's not going to be drying to the outsides. And those two, like having Andy's idea and trying to be able to put hardwood floors in, that's really what started it for us. But what it is now, I mean, when you look at the direction that we're going with high performance building, as Josh said, it's like we've got heating and cooling loads down, and we're still working on comfort a little bit, but embodied energy is kind of the next big hurdle for people in our movement to be working on, and it does make a difference in that direction.
Yeah, I think that covers the reasons I know. Does anybody else have another reason why you might want to reduce or eliminate the concrete, or did Steve pretty much cover it?
I have, if I can chime in.
Yeah, of course.
So Bruce King, in his new carbon architecture book, I forget who the author was who wrote this, but I thought it was interesting, was saying that in the next 15 years, we're going to add 3 billion people to the planet, and there's not even enough capacity to produce enough concrete to support all these people. So if for no other reason, there's not even enough concrete out there to support what we're expected to grow as a human race. Also, for every roughly ton of cement that's made, we release about a ton of carbon into the atmosphere. So I think those are some compelling reasons that were in the Bruce King book, anyways.
And also cost. I mean, you're saving all the cost of pouring that concrete because you're simply removing the concrete from otherwise the exact same system you would be using. You'd still be using the foam, and you'd still be using the subfloor if you're putting a wood floor in. So, and all the trucking, and sometimes sites are difficult to pour.
That was one of the early questions that came in already. It was the comparing costs. So just could we quickly just sort of scan the panelists and ask, like, has it been a cost kind of neutral or a cost savings situation, or have you found any cost increases in doing this?
I would say, like all questions about costs, it depends.
Mm-hmm.
like, for example, I found when I analyzed the costs of, we've done 3 of them, the cost was pretty much the same. And the only thing that would have changed the cost for us would have been if they went with like all ceramic floors or all carpet and didn't care about concrete under the carpet. I think if you keep the concrete and want to have hardwood floors, you've got all this additional expense that you have to do to manage that. So when you add all those other parts in with hardwood floors, it is cheaper to it is cheaper to eliminate the concrete. But then the concrete and the wood were relatively the same cost. But if you need a pump truck, you know, that could be $800. It could be more depending on access.
Mm-hmm.
And then actually one other part too is the how it's designed and how the elevations of all the parts go together can also add labor if you're trying to get it perfect. Like if it's a slab on grade house and everything has to line up perfectly, there's a lot more labor getting your substrate perfect versus if it's a basement remodel, it doesn't really matter.
Yeah. Well, let's jump into showing each of your systems. This is, I know each of you are probably used to doing long presentations. I've seen some of your presentations. This is the super duper abbreviated version. How quickly can you get through what's really unique about your system? If you have images loaded up, it's probably easiest for you to share your own screen, but if not, I can share my screen. In fact, I have Andy's article loaded up here. Maybe I can share your article, Andy, unless you're ready to.
Nope, you go ahead, Mike.
I think this will work. That's not it.
That's the article.
Yeah, that's it. It's a classic.
Oh, okay. Somehow I'm not seeing. Somehow my screen just went wacky. So.
No, it's there.
Okay, good. I'll trust you.
So I thought a lot about this, and I, of course, being an existing basement, I was very worried about moisture, both intrusion and condensation. Intrusion, I felt we dealt with well enough. So I was really concerned about keeping interior air from contacting the concrete. So of course, all the seams are taped in the foam. None of the ideas here are really original. I stole most everything from Joe Stiebrick, of course. One of the neat details I think I did, it doesn't really apply to the floor, but if you look up at the top, you can see I ran a piece of plywood on the bottom of the joists right tight to the mud sill, which gave me a really good air stop that I could work to, as opposed to having to deal with all of those awkward spaces above the mud sill and between the joists. But it's a really simple system. You put the foam down on the floor, you tape it, you throw your plywood down, the first layer running in one direction, the second layer running in the other direction. Make sure that you don't have any seams lapping directly over each other, and then I just screwed everything together with probably 1 5/8" drywall screws. It was really a no-brainer, and we ended up gaining 2 inches or losing 2 inches of headroom in the basement, which was acceptable. And that's always an issue with particularly basement refinishing in older houses where you've got maybe 7'8", 7'9" if you're lucky. This worked out very well. It did necessitate a change to the stairs because, of course, that bottom riser was nowhere near code compliant now. But there we go.
Yeah. Well, Andy, why would I've done this quite a few times using just putting down sleepers and then putting foam between the sleepers. Why did you go with this instead of the more conventional sleeper system?
Well, I mean, it avoided all of the cost and labor of the sleepers. They're just not necessary. The floor was relatively flat, so we didn't have to worry about any major depressions causing issues with the floor. And it gave us a complete thermal break. You didn't have to worry about the uninsulated area underneath the sleepers. It was fast, it was cheap, and it was thin.
Yeah, great.
Andy, what year was this article written in?
2005.
All right, so great article, and honestly, I'd never seen it, but you said you got it from Joe. Having worked with Joe, this is the exact, I didn't do the wall, but I live in a 1957 slab on grade Cape. And that's exactly how I retrofitted my slab on grade back in 1998. We did 1 inch of foam and then 2 layers of 1/2 inch plywood. And one of the absolute beauties of it was by only using 1/2 inch plywood in the whole house, we did end up with a few soft spots, but they were easily solved with a 3.5 inch concrete nail or 4 inch concrete nail that I would just drive right down the center of the soft spot.
Right.
And it would, you know, the 4 or 5 soft spots in there tightened right up. But it works surprisingly well. The other thing that's actually pretty cool is Joe turned me on to, I back primed or back sealed all of the hardwood floor. And so we get no moisture migration through this slab system. And my hardwood floors don't seasonally move at all in the house. They're tight as ever all year long. So
yeah, the floor that went on top of this was just a click together cork floor.
Yep.
And again, that's held up. Well, it's been 15 years and it's still held up very well. I think if there had been any areas where tile had been planned, then I would have done something like what you were talking about. If I found a soft spot, I would have, well, it's a little, you know, I would have run a Tapcon or two and tighten it down.
You have that ability.
Yeah. Well, let's jump over. Thanks, Andy. Let's jump over to Steve Demetric sent some photos, but I know this is a project Steve and Steve did together. Do you have it loaded up, Steve, or do you want me to load mine?
Let me see.
I can share mine again if that's easier.
Yeah, actually, I had a if I can pull it up right here. I had a drawing. This was actually a slab on grade project. Oops. Let's see if I can do a screen share.
Should be middle of the screen, the bottom.
Yeah, there it is. Yep. Yeah, here it came up. Yeah, so this was the one. This was kind of the evolution I did for a slab on grade house, and because one of the things that we were trying to connect the flooring. This is just an interesting detail. We were trying to connect this 2 layers of Advantech through at the exterior doors, and we also were struggling with elevations as well. So this is one of the key elements that I found after doing 3 of these is, especially if you're trying to get everything nice and level for the foam and for the Advantech, is we're creating screed points for all of we're basically down to 1/2 inch stone, and using tops of our footing to be the top of the stone, bottom of the foam, and then any interior footings. And then in this case, for example, we actually poured a little wall down the middle, so we could just easily just screed everything. And then we just put it in our foam, but then our foam ends up right above that 2x6 PT plate, and then the Advantech can actually come right through to the exterior, and we can maintain the air seal. And then if this is up a little bit high, it's easily shimmed. And then this one too, we've got a double stud wall, so we have a nice thermal break right down the middle there. So,
yeah. Steve, this is pretty similar to the one I did. I was worried about the floor not having any like solid connection to the wall. Were you concerned about that at all, or do you think it's going to be okay to have the wall and the floor not mechanically connected?
Oh, the interior and exterior wall.
Or the interior wall and floor system to your frost wall.
No, I didn't. With a double stud wall, all of the load comes through the exterior here, and so that interior wall there's just a partition. Yeah. And it could be anywhere in the house at that point. So yeah, okay. I wasn't concerned about that at all.
Great. So. Maybe let's move on to Steve Bazek. Do you want me to? Do you have images?
I mean, I have all of Steve's images from the project from his house. That I have the whole folder here. I didn't get a chance to sort them out, but is there a way I can?
It might be easier if I shared my screen again, because Steve sent me just a few.
Okay.
Yeah, so maybe do it that way.
Yeah, sure.
I think I sent you the article, Mike.
What's that?
I think I sent you the article. It has the pictures in it.
Oh, is that the best one to do?
Yeah, the other pictures there were actually my own house. So
oh, okay.
I'm actually sitting on a slabless slab right now.
Okay, Jake's going to make fun of my buttons again, but let's see. Does that work? Can you guys see?
There you go. Those are the pictures
Yep.
I have. Yep.
Right. So this is a JLC article. The title didn't come through, but yeah. Do you want to describe what's going on there, Steve? Or is this a good one, or do you want me to scroll?
Yeah, like the metric. Steve, why don't you talk about it? These are your guys, so. I mean, your
Yeah,
process,
actually,
so-
yeah, Mike, if you scroll through, you kind of get to where a little earlier in the work.
Okay. Just
actually, you can stop there. That was actually, in this particular image here, you can see we had our fill below is not level with our footing. And after trying to level this one, that's when we immediately made that change. And a little comment about fill, because I know a lot of people are asking about settling. That is an important issue to consider. And one thing I talk about all the time when people ask me about this process is that you need to have a really good excavator. That's really, really, really important. Someone that understands materials, that isn't going to dig a hole and then fill it with something that you're not aware of what exactly it is. And then the other part too is what material we use. We're fortunate that I have a really good excavator, and he also he has his own processing for recycling asphalt and concrete countertops. So actually all of our fill in these homes is 3" minus recycled asphalt, which basically once you put that in there, that's not going anywhere. He compacts it with his excavator, and we don't have to do multiple loads of gravel and fill it with water and spend a lot of time settling. So that's something that actually makes these projects affordable for us.
excellent. Well, let's move on to our Randy to show his system, and we'll come back around.
Okay.
Where's my screen share? Stop share. All right.
All right, I do have a SketchUp I did. Did it come up?
Yeah.
Yes.
We're all looking
Okay.
at it.
There it is.
All right, good. All right, so what I've got is we did I wanted to have a full foundation to begin with. We did an ICF foundation. My climate, I need 5 foot down to meet frost. So that's how we started the process. Yeah, there's some concrete in there, but the only way I was comfortable doing this process. We built the wall right off the stem wall, the ICF foundation. So the entire building was dried in before we built the floor system. I really didn't want that system getting wet because there was a poly between the 2 layers of EPS foam. So there's 2-inch or a little over 2-inch EPS foam. So we're sitting at about R20 on the floor system. The ICF foundation has got an R22 R value to it, so pretty well insulated for a climate. We ran the 2 layers of Advantech flooring offset. Again, Jake Bruton did this with Steve Basic. This was kind of based on their design. Again, having that completely dried in really was nice. The entire structure is built off the stem wall. There's no interior bearing points, so we were able to free span everything, build a floor system, and then come back in and put together the interior partition walls, which was nice.
Excellent. Thank you, Randy. That's good. Elizabeth, do you want to share your images, or do you want me to share them for you?
Why don't you do it?
Okay. I think I'm getting the hang of this. Let's see. How does that?
I don't. Okay, there's one. Do you have the? I don't know if you have this section as well, but basically we use these open web trusses.
Yeah, so flip through quickly the ones you sent.
Do you have the drawing?
Oh no, I don't know if you. I don't think you sent me your drawing.
Oh, that was in a separate email. But
oh shoot, I'll find it.
Okay. So basically, we're doing the same system as the Steves, and just by the way, we use that article to get through the building department. Because they ask, they never want to accept it, so we always take that article, and then I have to sign something. That we've had to do that on every single one. So that's cool. Thanks. So we build up with, we usually use Icf Foundation, and then we build up with 6 or 8 inches of EPS. We also like to put sometimes a vapor barrier between the layers of foam because that protects it, but not always. In this one, we did the open web trusses on top of the foam. And the way we built it, we actually did the same thing as Randy. The contractors wanted to build the house before putting in the floor system to protect the foam and the vapor barrier and everything, which proved to be pretty hard because actually, if you go back to that last one, Mike, or yeah, just blow up there. Yeah, so we built the walls first, and then we came back and we put the floor. We did the second floor. We framed the whole house, put the second floor on, and then we came back and did the foam boards and the open web trusses, and that just made it hard. The framers were really, really not happy because they had to block in every rim joist, you know, between the vertical wall studs, which was a pain in the butt. And where we had full height door, we had a lot of glass doors full height, you know, they had to block that all out in a way that was just back asswards. So they were kind of pissed. But it worked out really well. Otherwise.
Yes. Yeah, so I mean, this, you could call this a slab on grade. You could call this a frame on grade, maybe. Do you think that would be a more...
Yeah. Yeah. Yeah, because it did, we really had no room in this house. It was built on, the house was built on a ledge and we had a height limitation. So it was a 2-story flat roof house squeezed between, just squeezed. And so we needed all that space for plumbing, electrical, and HVAC, which we used it for, which it really worked well for that.
Yeah, so are these both the same image, just different scales then?
Yeah, the one shows the full height of the building.
Okay, got it.
Yeah.
Okay, great. No, thank you very much.
Mm-hmm.
And next up, or last up, we have Josh Salinger. Do you, Josh, do you want me to share images for you, or do you have some?
Let me give it a shot to share the screen here so I can use my mouse to kind of point around. So let's see. Hopefully everyone will see this soon. Yeah?
Yeah.
Yep.
Okay. So this was the idea of trying to avoid, you know, not only concrete, but also foam, petro foams, and trying to come up with a cost-effective way, a creative way to pull this off. And the 30,000 foot view on this thing is, you know, you show up at a perfectly flat site. It's the first thing you need. And then you basically scrape the ground of all the flora, right? So there's just minimal excavation. And then you would screw these helical piles. And for those watching that might not know what they are, they're essentially large screws that get screwed into the earth, and they can support the uplift and the weight of the foundation. There's also helical piers, which are like rods that get driven in, which can be useful in rocky soils and stuff like that, where the piers might not work. Anyways, you show up, you scrape the ground, you screw in the piles where they need to go. Then you would run your groundwork, plumbing, and electrical at that point. Then you would throw down gravel, and the gravel would act as the capillary break to, you know, stop moisture and vapor from coming up from the earth. Then our thought was that we would actually take some rock wool bats, not the comfo board, but actually the bats, and kind of set those a little bit higher than the ultimate elevation of the bottom of that CLT, the cross-laminated timber. The thought being that as we set that CLT down, they would actually compress those bats and create a nice compressed and fully, you know, touching all 6 sides of this box, so to speak, on the CLT. And that's kind of it in a nutshell. Now, what we'd have to do is get a vapor barrier into this thing. So we were trying to figure out, well, how the heck can we get a vapor barrier on the bottom of these things? And it occurred to us that we could use pond liner. You can buy pond liner at like 16 mils for 25 cents a square foot. And we could laminate that to the bottom of the CLT. And that would create our vapor barrier and be on the warm side of this assembly right here. So we are in a seismic zone here. So we actually did have this engineered with a structural engineer. And by setting these piles with a connection plate that's still kind of to be determined, we can actually run those to our H22 connectors in the wall, and this will work in a seismic zone too. Then the other thing we thought to kind of save on cost too is with the CLTs, and I actually called a CLT manufacturer called Structurlam. I believe they're up in Vancouver, BC, but they have a local office here in Portland. And they said that with those multiple layers in the CLT, we could use the top layer and use oak as the top layer. So we could have the first two layers just be typical spruce, pine, fir, and then put oak on the top. And then, you know, that could just be our finished wood floor right on the top of that. So we were like, oh, this is cool. We get a really high performing wall. We get a finished floor built in with wood. You know, we get a vapor barrier made with pond liner, which is cheap. We got all this time that we can save. We don't have to wait for the concrete to set. We can start framing right off this thing. And we can make it really airtight. And with the addition of the exterior insulation, it kind of encapsulates that wood CLT and makes for a long-lasting assembly. We're in climate zone 4C here, so that's mixed humid marine. So you may not be able to get away with this in all climate zones. We just have, you know, 4 inches drawn here. But we've been finding that we can actually meet Passive House here in Portland, Oregon, just 3 inches of exterior insulation. In this particular drawing, we had thermocork on the outside because I wanted to just do like an all wood, super low carbon assembly. So, you know, there's still some trickiness to it. Like when you meet the panels, you know, when they join, actually, let me see if I can scroll up here. In this particular foundation we were looking at, it was about a 1,200 square foot foundation. It was 27 by 47. These panels come, I think 14 feet was the minimum, or the maximum, sorry, here, and they can be as long as 40 feet. So we couldn't quite get the entire 47, so we kind of cut it down the middle. One thing we haven't fully worked out is with the movement of the wood, you know, how we create some sort of lap joint there that allows for movement while still, you know, is blocking the vapor from down below, and also allows for air tightness at those joints. And so that's one thing that we have some ideas for. And the other thing we have to work out is just the reality of, you know, when you have your plumbing stub outs, how are you going to land a really heavy panel? You know, we're guessing we're going to use a crane or something along those lines with this particular assembly. But how do you kind of thread that needle with the plumbing sticking up and then trying to land a large panel over the top of it? Open to ideas on that one. We've come up with some stuff, but no golden arrow yet. So it's kind of a nascent idea, even though I've been kind of stewing on it for about 5 or 6 years now. So if anyone out there watching this, or any of the panelists, you know, marinate on this or think about it more, I'd love to kind of open source this and come up with some ideas.
Yeah, so I got about 10 questions.
I realized we shortchanged Elizabeth a little bit. I forgot we had a bunch of photos for her. I wonder if we just want to just quickly go back to Elizabeth's photos and then we'll open it up to questions. Is everybody?
I got about 10 questions there too.
Okay.
No, let me get your screen. Yeah.
Yeah. Thanks, Josh. I appreciate that. That's a cool system. All right. So. Sorry to shortchange you, Elizabeth. Can you?
Oh, it's fine.
Is that the right screen? You can see what I'm seeing.
That's a good one.
Yeah.
So it's showing some ducts and plumbing and electrical, and we did end up spray foaming the rim band there. And
so like a big advantage of your system is you have access to mechanicals. I think that's a good.
Right.
So what drove the depth of the trusses?
You know, we started smaller, but we just decided as long as we were doing them, we'd go a full, I guess, a foot, 11 7/8, you know, to get the most out of. Oh, you know, one of the things was slope. Our longest plumbing run drain needed enough slope from the kitchen sink, so that was one of the drivers.
Gotcha.
Yeah.
So let me ask you this: when you Mike, you're killing me.
Okay, I'll go back. This is how's that, Steve? Is that a good
That's
one?
perfect. Yeah.
All right.
So here's a question. Why not, or a thought, did you think about minimizing the EPS underneath the trusses, getting rid of the closed cell foam, and just netting the top of the trusses and blowing cellulose in there?
We didn't. We didn't, but we could have. Well, my original detail also had cellulose. We had 6 inches of foam and then also the cellulose. And then we did some woofy modeling on it. And we just realized that it really wasn't doing that much for us. So we got rid of it.
The cellulose wasn't doing much thermally, or not doing much?
Thermally. Yeah. And also, I think the contractors thought it would be hard to work with that. This way we had everything open, and it, how long it takes to get all the subs to do their thing.
Yep.
So
the reason I asked, the very first passive house I did a very similar floor system. We didn't use floor trusses. We used 2x8s, and we built the floor frame above the ground, like a foot or so, and then we netted it and blew the whole thing with like R80 of cellulose, and cambered the joist base with it, so when they screwed down the Advantech, it crushed it all. But
a question I have on this type of system is are there any code or building science issues with your it's sort of like a crawl space. It's sort of like an inaccessible crawl space, which the code doesn't like, and its interstitial spaces can create some moisture and airflow issues. Were there any concerns with that?
No one raised any flags about that, and we didn't have that concern.
And if you did have that question, Mike, from a building inspector, I just have the HVAC guy do about 4 or 5 drops inside that truss plenum, drop about 50 CFM, get a nice radiant floor out of the deal, and tell them it's a fully conditioned space.
There you go. Perfect.
And have a transfer grill to the upstairs in a bedroom or 2 or something.
Right. No, that's great. Okay. Is that pretty much covers it, Elizabeth? Do you think, for yours?
Yep.
All right. Let's go.
Well done.
Thanks.
Excellent. Let me turn it over to Brian, who's been looking at.
Don't forget to go back to Josh's detail. I still have my 10 questions.
You got questions on Josh too. Geez. All right. Let's have two questions for Josh.
I have a whole lot, because I've tried to do similar things, and I run into a whole host of problems there that I want to see if your problems are the same as my problems.
Yeah.
So.
Would you like me to share this back? Would that be helpful?
Yeah, please put the detail back up.
Okay.
And you said you're climate zone 4?
4C, yeah.
4C, yeah. All right. So, a couple questions. Helical piles. Does your structural engineer take responsibility for the whole system?
Yeah. So the helical pile manufacturer actually will deliver some engineering to our structural engineer that they'll incorporate into that. But I believe from a our structural engineer would be kind of covering that liability under his umbrella.
Right. All right. Yeah. So the helical pile guys give you reactions to the top of the pile, and your structural engineer takes that information and designs accordingly.
Correct.
Okay.
Yeah.
Because I've done some helical pile work, and my structural engineer will not go below that metal plate. He said, I have no idea, what's down there unless you do some pretty advanced geotech at every pile location. You have no idea what's going on. So, second question, the metal cap plates, the helical piles, were they attached to the pile upon driving, or were the piles cut and welded those plates to them later?
Right. So now we haven't built this. So this is kind of.
Oh, this is unbuilt. Okay. Yeah, so what's your plan then?
So the current plan is that we're to be determined, right? So the thought is that we would probably weld something on the top of the pile afterwards, which would require that special inspection and inspector there to do that, but also to be engineered accordingly. I know that the structure lamb, the CLT manufacturer, has a lot of connections, because they're doing a lot of stuff with commercial buildings now. And she seemed, when I was talking with her pretty confident that we could find something that would work in this scenario. But to answer your question directly, no, it's to be determined.
Okay, so the CLT manufacturer, now, do they handle the engineering of that dance floor, and they give that to your structural engineer? I mean, who takes the responsibility
kind of thing with piles? Yeah, same. So they're going to deliver a package that's going to say this is the the deflection and the CLT over this much, and so on and so forth. So yeah.
Yeah, I mean, honestly, I was surprised to see the panels as large as they are, and surprised that, I mean, you're probably talking, yeah, we have this 4 1/8 of an inch going 23 feet. It'd be interesting to understand what the deflection is there. I mean, I understand that it's laminated timber and it's put up, but that's a hell of a span for a 4-inch dimension.
Yeah, so they also make it, and you can get it as thick as you want. So I imagine your structural engineer is going to let you know what we need. In this particular case, we did have that engineered, and just the 3 layers of ply was sufficient.
And the other thing that, I mean, did you have conversations with the CLT people about hacking up that diaphragm? Because I can't imagine cutting holes and doing stuff in it.
Yeah, sorry. They have a lot of great handouts saying, similar to like like an I-joist or a beam, you can drill a hole within a certain distance of the edge that can be up to this big without any issues.
Mm-hmm.
I wonder if another way to minimize your peers but provide structural support, it would cost more, but if you did comfort board instead of comfort bat underneath there, I mean, comfort board is supposed to be adequate under slabs. I think most people except for Dan Edelman, the Rockwell guy, is a little bit nervous about it, but it's just I wonder if that's an option.
I think the problem that I have with that, Mike, is you're kind of torn between 2 decisions here, because the comfort bat is going to offer you the flexibility to compress, so that if the ground is irregular underneath it, the bat will pick up the slack of the irregular stone surface underneath. If you go to something hard, then any humps or that in that crushed gravel, if that's not perfect, then they're going to reveal themselves when you go to lay the CLT down, because the bat isn't going to be or the board isn't going to be as forgiving as the bat. I'm not saying that I don't think it's a good idea. I just think all you've done is displace the problem. You haven't necessarily solved it.
And that was actually part of our thinking. You're right, Steve. So again, we were trying to think, how can we make this as quick and easy as possible? And so that was part of our thinking, that we can just, take out some of those bumps and humps with that.
Nice. Any other questions for Josh or anybody else among panelists? We're actually at our 5-minute warning time. So actually, let me switch gears a little bit here. Sorry. We have about 5 minutes left until 7 o'clock. So at 7 o'clock, we'll shut the official discussion, but we'll keep things open if people want to stick around for a while. I would like to sincerely thank all of our guests and our audience, and again, Green Building Advisor and Fine Home Building, and my co-hosts for all the time and effort that goes into making this happen. But so let's switch over to at least make sure we get a couple of audience questions in here, and then we can do more free form after 7 o'clock.
Yeah, so the first question that we got, I think, is a good one to ask. If you got any particular pushback from your local building officials, and how you appeased them if you did.
I said, I always have to sign some special piece of paper, and I always show the JLC article as backup. So far, I've had to do that on everyone.
I can say I've never had any pushback at all.
Yeah,
no one's even the inspectors come in and they don't even know what they're standing on.
It's a short conversation, Brian, because you can go in and talk to the building inspector, and you can say, listen, we have 2 scenarios. You can accept my stamp drawings where I take full responsibility, or I can do it your way, and you can write me a letter saying that you accept responsibility for the way you choose to do it.
That's good.
We actually did have an issue in Portland, Oregon, and we did actually submit the article that the Steves wrote, and we did an adjustment. We had to pay for it. It took about a month, but they did let us do it.
Excellent.
Yep. Oh,
I think, as far as the code goes, the full basement one that I did with Steve is probably more scarier to a building inspector than, say, the house I did with Jake. And the reason is because you have the, you have the ground pressure in the basement that you don't have in a slab on grade house. I mean, the house I did with Jake, and I apologize for not having a detail of that, but it's basically a stem wall that's buried in the ground. But I think this system is exceptionally well suited for that. And Randy's is pretty much there, where we have ground pressure on both sides. So the question is, what do you really have to lose? The slab there is certainly not doing anything.
Yeah, I think one of the comments that Steve, that you and I came up with when people were questioning us about the foundation and pressure at the footings, and being in New England, you look at any house that's built before 1900s on a rubble wall.
Yeah,
and they have a lot of them have full basements, and they're not, if they're crumbling in, it's usually from the top down,
and they don't have slabs. I grew up in a house.
And they don't even have slabs.
Yeah, I grew up in a house that had dirt floor and rubble stone walls. And
the slab to footing connection can be engineered very easily. Like, it's standard for us to key our walls into our footings. You can always add extra rebar that comes out of the footing to keep the wall attached to the footing. If you're worried about that whole thing bowing in, you can just add 2 more pieces of rebar into your footing, and it's going to be stiff in the horizontal direction that way as well. Really what we determined after beating it back and forth, the slab's not doing anything.
No,
it's just taking up space. And at least in the homes that we're building in our climate zone, it's doing is taking up space.
And the high-tech solution to that, Steve, too, is if we ever did get serious pushback, all you'd have to do is come in with some intermediate footings that run through the middle of the house. It would be a little bit more concrete, but it's still a hell of a lot less than pouring a slab.
Yep. Yeah.
So I have a little pushback on that, because we have a lot of expansive soils here in the Midwest. We're constantly told we can't even backfill until we frame our first floor diaphragm because of all the expansive soils that are going to push our walls in and slide our footings across.
That code's ignored up here too.
But my question was going to be, is there a clever design detail where we can tie that floating diaphragm into our footing or the base of our foundation wall and resist some of that expansive pressure? Is there something we can do about that, or is that not a good idea with Advantech as a diaphragm? Is it not going to perform that function? Will it balloon up? And
yeah, I would think the Advantech would balloon up. But I mean, it depends on where the pressure is and how much pressure there is.
Sure.
You know, like if it's a slab on grade, as Steve was saying earlier, you could just pour an intermediary wall. Higher PSI concrete, add more rebar.
And Travis, you really have 2 arenas where you can solve that problem. You could solve it underneath the foam, or you could solve it underneath the interior walls. So the first one suggests that the slab doesn't move. They actually make fillers that can go underneath different scenarios. I mean, all of Colorado, I did a house out in Colorado that had that. I mean, they actually, some builders build a crawl space under the basement, and they let the crawl space floor float up and down, and it's measured in inches, not fractions of an inch. But you can deal with it there. There's actually companies that make fillers underneath, compressible, like honeycomb type filler that you can put under the slab that'll take up a couple inches. But they also, you can come on top, and in the house that I did out there, we did a bottom plate that literally sat about 2 inches above the slab on these, like, I don't know, they were probably 20 penny spikes that allowed the slab to literally slide up and down them and pick up some of the slack, so you wouldn't be crushing the walls with the slab movement. So
I guess my concern is more of the walls buckling in. Like, there's a massive industry in our area for piering walls from the inside to resist the pressure pushing in, and the slab resisting that. I'm not so much worried about uplift. I'm worried about pressure out.
Yeah, well, that's what I'm
Travis,
saying.
don't you think that the majority of those walls buckling in things are not caused by the soil? It's more caused by cold pours from the 30s, 40s, and 50s in our markets?
Where the hell did you come
Or
from?
we have a cold joint running horizontally? I don't know who let me on. Somebody told me that I should feel free to jump on. Sorry.
Hey, Jake.
I'm not qualified
you
to
too, Steve.
assess why that's happening. I am just frequently told how I can't start backfilling because I don't have my first floor diaphragm framed. And so I wondered about that at the basement level. I was just trusting that these people know what they're talking about. It's got to be resisting, but I guess maybe not.
So we had, and I'm kind of going to group, for the sake of time, I'm kind of going to group some questions together here, but we had a bunch of people ask about the implications with a concrete-free slab, the implications of soil gases and radon, and the necessity of the vapor retarder, and also any changes to drainage, sub-slab drainage. So if anyone wants to jump in with any of that, I think it came up a few times.
Yeah, well, and let's try to hear from maybe Randy or Elizabeth. We haven't heard from you guys as much lately. What do you have to deal with radon? Is that an issue where you are?
Yeah,
where we are, go ahead, Randy.
we got to layer crushed rock in with the pipe that goes up through the roof. It's passive. It's not an active system, but it's in place.
Same with us usually. I mean, we usually test for it, but usually we're putting one in and often with a fan. But we're using a lot of crushed stone underneath the whole system, and sometimes some drainage pipes under the crushed stone to bring water away underneath the site.
So it's really not much different than radon mitigation under any slab. It's the same thing. You're just skipping the concrete layer, right?
Yep.
Exactly.
Another question was, would a concrete-free slab work in a garage?
Yeah, they call those wood barns.
I've done 2 frost-protected shallow footings for garages and tractor sheds. So what that saves you is the concrete that goes in the stem wall. It's not perhaps as good as if you're doing a concrete-free foundation, but it does save a significant amount.
Did you have to do like wide frost wings?
Yep.
Andy, yeah, just up here, unheated buildings with frost-protected foundations need 5 feet of foam outside of the corners. So it gets
depends on your climate zone.
Yeah.
Where I am, it was only 4 feet. I got
Okay.
the ASCE, American Society of Civil Engineers document, showed it to my building inspector. He said, "Oh yeah, that's really cool. Go ahead." It's not hard to do. And it's a way of minimizing. You have no stem walls. Where I live, climate zone 5, we have to go down 42 inches. And that's a fair amount. I was going to do block, and I really am too old to lay that much block.
Yeah.
Also, I had someone in our area that tried to do, they did a barn and they tried to do the wood floor continuous through, and the building inspector wouldn't let them because of the fire code. They have gasoline leaking out of the car, catches fire.
Yeah, let me back up a little bit on the frost-protected shallow footings too. They are in the IRC for heated dwellings. They're not in the IRC for unheated dwellings. But the same ASCE document that the IRC references for heated dwellings covers unheated dwellings as well. They're just more details that weren't incorporated in the code. And if you have a reasonable building inspector and show them that document, it costs like $40 to buy it. It's not a big deal. They'll just let you fly with it.
A couple of people also asked for the panelists to kind of weigh in on whether they would like a concrete-free slab to be sort of their standard slab detail, and if not, why. And I guess that also could be looked at as when is this is not a good idea? When doesn't it work, or when would you avoid this detail?
I would only do it with contractors that I trust. I wouldn't put this project out. I wouldn't put a project like this out to bid. I wouldn't feel comfortable doing it that way. I would have to know who the builder is and understand how conscientious they are to agree to do this with them. And it's not that it's complex or difficult, but this is probably a system where it's, and I'll let Jake and Steve weigh in on it, but it's a system where it's real easy to say that's good enough when it isn't good enough.
Yeah, I would add to that applies to any high performance building.
Yeah.
Air
Also,
barriers, vapor barriers throughout the whole structure.
I would say that our contractors we've done it with, they feel like it's so hard to get the whole system super flat, that's a lot of work and it's really hard. And then I know one of my contractors at least feels like in the 3,000 square foot, 1-story house, we did the whole floor like this. It's true. When you walk around, when you get to the haunches at either the edges or we have a center load-bearing wall, at both those places, you can feel ever so slightly the difference in the floor. You know, it's ever so slight, but you can feel it, like the slight difference in the bounce and the height. And so he's not a huge fan because of that. I don't mind it.
Yeah, and I mean, I would agree with you on that one, Elizabeth. I do a ton of work down in the Southwest where we just do concrete slab houses. And so I get a little annoyed when builders say, oh, look at this. See how this is up 1/8 of an inch? It's like, come here, I'll take you down to a 3,000 square foot house down in New Mexico where the center of slab is up 1/4 of an inch. And it's all concrete. So the idea that you're going to get perfection because it's a concrete slab and
Concrete's
this
never
isn't.
perfect.
Yeah,
No.
I don't buy that argument any day.
But Brian, to answer part of your question though, for basements, that's our standard now. Like that's like the room I'm in right now. There it is right there. I wouldn't do it any other way in a basement. The only time I would not do it is if the soil on that site or if the ground on that site was just a difficult site, really high water tables, bad drainage. But again, you got to be careful whatever building you put on that site. So
I'm with you, buddy. Water table is probably number one concern on that.
But if it was a water table issue, I would just raise the foundation up, put enough drainage in, and you'd have to, basically build a Noah's Ark at that point. And if the water table is that high, you got bigger problems.
Hey, Steve, should we mention Craig's trip to Colorado and what he found when he came home?
Oh, yeah, I totally forgot about that. Yeah, for people that are worried about water damage. So the first one that Steve and I did, the main water line coming under the slab into the house from the street, where it went into the water meter, burst. And he was away, and he came back 2 days later to find, I think, 8 inches of water in that basement, and it held it like a swimming pool. And it was about 1 inch away from getting to the battery. So if he walked down the stairs into the water when it was into the battery, that wouldn't have been good. But everybody survived, and we had to open we had European doors going outside, and we opened those up, and it took a couple hours for all the water to drain out, and it dried perfectly. It went back together like a normal, any water basement remediation.
Yeah, but the Advantech stayed intact, right? I mean, it was.
Yeah, the Advantech was only
intact.
screwed together, no glue or anything. But the pressure of the exterior walls pinning down the edges of the Advantech was strong enough to keep the water from getting in between the layers. So we actually pulled some layers apart, and the water wasn't even in between the layers. Even at 8 inches, that's a lot of water column. That can do a lot of damage, if there's easy access to get in. But just like air pressure differences, if you need an inlet and an outlet, and if the outlet stopped up, the air can't go in. Water couldn't go in either. So we drained the whole house out. We had to pull all the floors out. We cut 2 feet of the sheetrock around the bottom, pulled out the insulation, and then we just put it back together like a normal house. So.
One thing to be added to, you asked about, would you use this for your typical detail? And one benefit is, and we haven't talked about this yet, is just constructability. In what order you do this, right? So here in Portland, Oregon, it rains a lot. And, you don't want to have a vapor barrier, with your slab and then have it rain. Because you're just going to have a pool of water that then you have to either suck out and put your plywood down on, or if you had the plywood down and then it rained, you're just asking for a big mess. So when we're talking about doing this in our upcoming project, we're simply going to do the groundwork, plumbing, throw down some of the gravel, and then frame the house on that gravel, dry it out so we have the roofs and the windows in, and then you have carpenters come in and actually lay down the plywood after that. So when you're working in climate zones that are, cold or snowy or wet, it actually could be an advantage because you can actually install that on your own schedule. You're not waiting for subs. You don't have to worry about all the drying out of the concrete. Also you can, if you do that in-house, you might have a better margin on your in-house labor than you would by subbing it out too. So it could be even more cost effective. But there is that constructability issue where you do have to do it kind of after the house has been framed.
Joshua, that's exactly what we did. We because we were using lime waste underneath, we got it to rough grade, framed the whole house, zip taped the roof, everything, and just left one window out all the way down to the ground. We left the sill out, and then we were able to drive equipment in, everything, while we were completely watertight and we didn't have any concerns. And then our in-house carpenters were able to get in there and lay our screed and our Advantech and everything, out of the weather where we didn't have to worry about things changing. I also, real quick, had a recommendation for you. You're talking about setting those panels in place and trying to figure out how to do that with your plumbing coming up. Just leave that vertical pipe unglued at that last joint. So after you come out of that P-trap or whatever, that turn, just leave it unglued, leave it where it is, measure to it, pull the pipe out, set the panel, stick it back down and with glue on it.
That's a good idea. Thanks. Yeah.
If anybody's interested, I do have my detail that's pretty similar, I think. And it kind of
no, we don't care.
Yeah. Well, I think it goes with what Josh is saying because that constructability is probably the worst part of it. Yeah. Let me just show this quickly.
While you're bringing that up, I had a project where we were planning on doing this, and we ended up actually pouring the slab because we moved out of summer and into the fall, and the builder didn't want snow and all this other stuff that he had to deal with the dirt inside the foundation. So, seasonal plays a role.
Yeah. So I wasn't as concerned with constructability because this was an owner built project, and there were some specific things, and because of the site, I was actually worried about the frost wall, grade beam, whatever you want to call it, tipping. So I wanted to have the subfloor continue out, and we went back and forth and decided instead of doing the double layer, we actually did sleepers, and I did the math. There's no compressibility issues with sleepers. So if you instead of 2 layers of Advantech, you can just do 2x4 sleepers, and the Advantech flooring ran out onto the mud sill, so it kind of locked the flooring in with the stem wall. But I think but the problem is then that you have to this whole floor system is vulnerable to rain, so you really have to hustle to get the shell dried in. So I think you guys have me convinced that maybe I was being a little overly cautious there on constructability.
Yeah, I think with a lot of these high performance details, making them constructible and making them so that the average builder isn't afraid of them is really, really important if we want it to happen. Because the average builder, I wouldn't build that, Mike, because I know it rains. And as soon as I start, it's going to start raining.
No, it was this
kind of Murphy's law.
Now this we came up with this. I hadn't read. I know Steve and Jake published their version of the slab free, slab on grade, and later Randy did it. I did this kind of blind, only based on your article and talking with the owner builder. But no, I think this was a prototype, and I think constructability is definitely important.
And Mike, your detail to solve what you want to do and then solve Steve's constructability, it would be simply by just going to the next larger size for that bottom plate. So you have a nailing flange there to bring the Advantech into and screw to.
Oh, actually, you know what? Yeah. That actually would have worked just fine without even changing it, because I already have a 2x8 plate, so I could have just you
could have just stopped it there and framed the wall on top. Yeah.
All right. Well, that was dumb. Travis had a good private question, but I think it's good to share. Is there a carbon what is the carbon accounting on Advantech versus Portland and concrete? I mean, Advantech is not a zero carbon material. There's a lot of petroleum in there.
Actually, I have exact numbers for that, Mike.
You do?
Because somebody brought that to me a couple of months ago, and I was talking with Mark Rosenbaum, and he has. I brought it up earlier today.
Oh, right, Stephen.
A 4-inch slab is is 231 to 318 kilograms of CO2 embodied CO2 per yard. The Advantech is 0.74 kilograms of embodied CO2 per square foot. So 2 layers of Advantech is 1.4 kilograms of embodied CO2 per square foot. So plywood is lower, but that's not the only thing is that it's not accounting for any additives you can put into the concrete to lower the embodied energy. That's standard Portland concrete, quickcrete bag mix, basically.
Right. So maybe best case with admixes, maybe you could reduce the embodied carbon by maybe 30% or something if you really load it with admixes, but it's basically its
average is about half of the embodied energy.
Mm-hmm.
Well, the other thing to account for, though, is and part of the reason that we ended up where we did, Steve, is if you're trying to put a hardwood floor down there and you put in the slab, you're still putting one of those layers of Advantech back.
Oh,
right?
Yeah, that was, yeah.
So
one of the main reasons, like when people look at the cost argument, it's not just the CO2 cost, but you get all that labor and material to get it ready for whatever the finished surface is.
And with wood, the insulation still exists too.
Yeah.
And with concrete.
And there is certainly an argument for, let's say, elderly health, walking around on slabs versus walking around on wood floors. There's a huge argument. In the Southwest, a lot of people hate the slabs down there just because they feel it in their knees.
Yeah, I mean, what I tell clients is if they like the look and want a concrete floor, then to me it still makes sense to do an exposed concrete slab on grade. It's the least expensive way to get a high performance finish. Yeah, there's embodied carbon, but just it's fast, easy, simple, relatively inexpensive.
Did I just hear you agree to using concrete and filling my atmosphere with carbon, Michael Maine?
It's the best.
Did we just get that recorded?
Yes, you did.
Okay.
It's yeah. But if they don't want concrete, if they want a wood floor, then sticking concrete in the sandwich, there's no reason to continue putting the concrete in there. If you want a wood floor, then just don't do the concrete. But if you want a concrete floor, that's still probably the cheapest means to the end. In my
it absolutely is.
Yeah.
Well, Mike Gurton's working on a design using PT foundation instead of using a stem wall.
Yeah, he's trying to do
a couple rubber bands, some PT.
It'd be PT from some decks he took apart last month. He wants to do PT walls with the Advantech flooring.
At what point does the insurance kick in there, though? I know maybe less with the slab, but once you start doing PT stem walls, all of a sudden the insurance people get real funny real fast.
I grew up in a concreteless basement foundation, all-weather wood foundation. For those of you that have gray hair, no offense, Andy, probably remember that all-weather wood foundation movement. And I know the people that live in it now, and they've had no issues with insurance or anything like that. They think it's a regular house. Their insurance thinks it's a regular house. So.
Yeah. There were multiple articles about that in Fine Homebuilding back in the 1980s. It's a thing, I think, mostly in the Midwest. We never saw much of it up in the Northeast, but I remember those articles coming out of Iowa.
That basement stemmed out of the fact that my dad didn't know how to pour concrete.
I don't know if any Superior Wall people are listening, but I wonder if they could pour like a little 3-inch waffle slab that had wood slats embedded into it that you could drop down into a basement module, as a module, and then screw Advantech or hardwood floor or something to it, like their wall system. Just take that down to a micro level.
Interesting idea. Well, I'm sure we could all sit here all night talking building science, but I assume other people need to get dinner as well. Should we wrap things up? Any last words from anybody? Are we good to go?
I would say, hey, Josh, send me an email. I'd like to talk more about your detail.
Will do. I'll send one over.
Nice. Well, thank you so much for you guests. I know this was a chunk of time, and really appreciate your thoughts. And thank you to the audience for joining in again, and to Green Building Advisor and Fine Homebuilding for helping us out. And I hope everybody has a great evening.
All right. Thanks, Mike.
Thanks, Mike.
Everyone.
Thanks, Mike.
Thanks, all.
Thanks, everybody.
Cheers.
Yeah, I had nothing to add to tonight's discussion, but now I'm like, oh, concreteless slab. Yeah, absolutely. Like all the way. Let's do it.
You got
Yeah. Why would you do anything else?
Right? I mean, it seems like a no-brainer.
Just
Yeah.
standard now. It's in every, cut and paste detail for every architect and engineer across the land.
For sure. Who wants to share their details? Yeah, there were some good ones on here.
Mine's in a magazine, so just go get that issue. It's already been gone.
I think Mike shared most of the article links in that, but maybe we can get it up into the record as well on the YouTube channel. Some links back to all the articles.
Yeah, the one I didn't get was the one that Steve and Jake did together. Steve, was that pro tradecraft?
I can send you.
JSC?
I can send you a PDF detail. It's not a
Okay,
problem.
great.
Yeah. Yeah, there's one, and something I did share with you guys too that I found was really helpful. Is it's just that random list of dealing with the details.
That was a really helpful list. There were a lot of good notes in there.
A lot of nuances to this that could easily turn this into a disaster. And making it builder friendly, it's super easy to do if you design it and layer everything properly and choose the right materials to go in. Because there's a lot of stuff you can put underneath the foam. A lot of foams to choose from, a lot of thicknesses, a lot of vapor barrier materials, and all of those things have a big part in how this goes together. Like, where does the vapor barrier connect through under the sill? Like, how good's your foundation guy? How good's your excavator? So, a lot of variables there that can make or break this very easily.
Sure.
Yeah. Very true.
Shut up, Randy.
Mr. Chatty over there.
I like the colors of your house, Randy.
Yep.
It's a Prince house if I ever saw one.
Minnesota.
Hey, Josh, is that a house that you built in your background?
It's one that we're currently, it is something we designed, and another team in town here is actually building it. So it's a planned development of 11 new homes, all zero energy. And this is the condition they're in. They don't have gutters on yet, but they're almost done. Yeah.
Sweet. Is that the Going Street project?
The Going Street project, yeah. So it's
sweet.
panelized. Yeah. It's got the Gutex fiberboard on the outside. The dual crosshatch rain screen. I'm working with Asa Christiana on writing an article about this. That's going to be. Hopefully, we got to get the final pretty photos done in about a month or two, and then I think it's going to be in Fine Homebuilding.
Yeah, we're excited about it.
Cool.
Did you just say panelized? Where on the West Coast do you get your panels done? Oh, because that I could talk about.
Yeah, right.
Next week.
This is a longer conversation, but we with a company called Phoenix House. They're based out of Colorado Springs, Colorado. Let's talk about, global warming potential. It's probably not great to ship your panels across that many states. You can wonder how smart that is. But the reason we chose them was that they were going to be opening a office and branch here in Portland. And after we signed the contract with them, they decided they weren't going to do that. So we were like, so the best laid plans, we thought we were going to be hyper local with that, and it didn't work. It didn't go well, there was some stuff we would do differently with them next time. Put it that way.
Like all good panelization projects. They're like, oh man, that did not go the way we thought that would.
Yeah,
been there, done that more than once.
Yeah, for all the talk of this is the future, it's like, wow, we still got to work out some kinks here. It's it worked well with 11 homes because we actually did save a lot of time. And it was really intentional because there's large interest payments on this large project. And that time savings actually turned out to be significant enough that it not only, was cheaper than the premium of going with the panelized, but also kind of was still cheaper than all the issues that we had with the panelized. So it did work out.
Josh, do you know new energy work?
Jonathan Orpin?
Jim Muha said that they're in Portland. Are they panelizers?
So yeah, Jonathan is a friend. His house that he built here, the Vermont Street house, is one of my favorites. It's a beautiful house. And he is, yes, he's on his way to starting to do some panelized stuff. I can't really say much more than that.
Okay. Non-disclosure. No, that's great. Well, I think we're gonna just keep chatting, but I think we need to do our forced shutdown here, if because otherwise we'll just keep talking all night. But I hope you all come back and join us next week in the audience, and we're going to be talking about panelizing next week. So it should be another interesting one.
Thanks, Mike.
Look forward to it. Thanks, guys.
Thank you, all of you, for such great insight.